Okay, good morning, all. Am I audible to you? Okay, thank you. So, this is just to recall the last class previously we have discussed the concept of higher order partial derivatives. And we have seen that when we actually change one variable at a time, then we see this type of partial derivative. But there are possibilities that we can have more higher orders. That means of this form derivatives. Also, we have mentioned that the total differential of a given several variable functions. So that dz is called the total differential of set. This is not derivative. This is differential because we have only dz. If we divide by some other variable dt, suppose this is here it will be dt, then we will have the rate of change. Unless we don't have the rate of change, we cannot say there is a derivative. Okay, so we call it a differential. Remember this name, total differential. Now this differential will be when we allow this delta x goes to 0, this goes to 0, then this function actually can be written as dz equals to del f del x into dx plus del f del y into dy. Okay, so there is another, this is theorem 3 for total differential. It has one corollary. If we have fx and fy partial derivatives with respect to x and y of the given function are continuous throughout the region, then f is differentiable at every point of the region. Okay, and differentiability, as we know that differentiability will imply the continuity of it, but continuity does not imply the differentiability because if you know this is a continuous function at all point, but at x equals to 0 it is not differentiable. Continuous everywhere, every point x belongs to R. Every real number, if you think this the real number space, then it is continuous everywhere but not differentiable at 0. So continuity does not imply differentiability, but differentiability definitely implies the continuity. Now we will recall the chain rule of ordinary differentiation. When we have a function w is a function of x, f of x, and there is one other intermediate function x is another function of t. Then the chain rule, if you remember, there is an intermediate variable, this is dependent variable, and there is the independent variable. So if you consider all these cases, we have seen that derivative can be written in this form. Now what will happen for function of two variable cases? That means w is a function of x and y, and this x and y are also function of t. Then what will be the chain rule for these functions? So partial derivative. So this is actually the chain rule for partial derivatives. So this is given by the theorem. Proof is actually omitted for our course. So you need to remember this theorem. In fact, this formula. And the dependency diagram is here given. This is the dependency diagram. Here, this is our dependent variable. And at the bottom, we will have independent variable. In the intermediate case, we have two variables, intermediate variables. Okay. Now, since these are only single variable function, so that is why we will have ordinary derivative. But this w is a partial, it is a several variable function, so we will have partial derivatives. And if you remember the total derivative, for total differential formula, from there, tw, you will have fx times, you will have dx plus fy times dy. Now, if you derivative this with respect to dt, then you will have dt, and the formula will become of this form. In fact, this is another. If you try to evaluate the function, the derivative at any given point x naught y naught. So t is evaluated at this point. So this is actual meaning of this form. Okay. Now you may be wondering that where we can find such functions so that we can use these derivatives. In fact, today we will see two interesting examples where you can find several variable functions, and these derivatives will be useful for these cases. Now let us take one mathematical example, one numerical example. Okay. So here, if you try to write the solution here, it will be u is a function of x and y. It is given as x cube plus y cube. Here x is a function of, for example, phi of t. That is a cosine t. And y is given as, for example, psi of t. This is given as b sine of t. Now you want to find out du dt. Okay, by theorem, by previous theorem, by this theorem 5, what we have? We will have del f del x into dx dt plus del f del y, then dy dt. So we want to find this one. So let us try to find out. And also verify the result, whether the result is actually true or not. So what we have to do? First we need to find out del u del x. If we differentiate with respect to x, then what will happen? Y is constant, so it becomes 0. So 3x square plus 0. It is nothing but 3x square. How about del u del y? Because we need to find out. In fact, not u, this is f. Because our function is given as f. Okay. So this is nothing but 0 plus 3y square. Again, this is nothing but 3y square. Also, I need to find out this value, dx dt. So from here, dx dt, if you differentiate, remember you need to differentiate. Okay. You need to write partial differentiation with respect to x and y. So differentiate with respect to t. We get this one. This is ordinary derivative. So here you will get minus a sine of t. Similarly, we will get dy dt from here. So b cosine of t. Now if you substitute these values, so du dt, this is del u del x del x, sorry, dx dt plus del u del y, then this is dy dt. So from here you will get del u del. So for this one we have 3 x square times minus dx dt is this one, a sine t plus 3y square times b sine b cosine of t. Okay, now we want to simplify it. Tell you, remember this is du dt. So this du dt is actually minus 3a x square. So in place of x square you can write, because x equals to, you have a cosine of t times, already we have sine of t, plus, so 3b times b sine t, then whole square in times, let us say, so this is b cosine t, so this is cosine of t. So you get here minus 3a cube cos square t into sine square t, plus this is 3b cube sine square t, sorry, this is sine t, times cosine of t. Okay, now let us call this one as 1. Again we have u equals to x cube plus y cube. So you can write, if you substitute this value, u equals to, in place of x you write this one, a cube cosine cube t plus b cube sine cube t. So if you differentiate with respect to t, because it is now becoming in one variable case, only t, so you get du dt is minus 3a square cosine square t into, there will be, because of chain rule you will have sine t another quantity, so this is 3b cube sine square t, because of the chain rule we will have cosine of t in multiplied, so call this one as 2. So from uh, equation 1 and 2 we get the same value of du dt, hence the result verified. So this is what you needed to show. So verify the result also, find out this value and also verify this is correct or not. Okay, so in this way we will try to verify these functions given problem. Just tell me. No, this is a function. Yes, it's actually there is a typing. I would say this is what, right? Yeah, from one and two you can see. Oh, this is typing mistake. I'm writing. Now, what is your doubt, sir? This was X and Y are dependent. No, no, no. They are intermediate. They are not dependent. Dependent is U. U is dependent variable. See the structure here. This one you are talking about X by A. Yeah, that is one. So why? X and Y are not dependent. We are not focusing on this curve. We are not focusing on this curve. They are intermediate variables. See the structure there. You don't think about their curve. Okay. Whether their graph, you don't know bother about their graph. Here the problem is if this is given a function of two variable where these functions itself are also some function of some other variable. So here how much you get? Here you get one dependent variable, two independent intermediate. Actually they are intermediate variables. You can call them when it is not there. They are then in that case they are independent because they will define this w. W is dependent on x and y, and of course these x and y are also dependent on t. In fact, what you have observed is actually correct. Yeah, they are dependent variable, but with respect to whom, that is important. There is another variable is t, because we have so many real problems where you can actually, for example, I will tell you this one. This is one kind of uh, several variable function. So this example is taken from the government of India income tax department. So if you try to calculate the income tax of a person, if the income is below 5 lakh, the net taxable income, okay, then it happens to be zero. But if it is 15 lakh, then the person has to pay this 2 lakh 70,000 actually. Uh, what is it called? Income tax. So this is, for example, if you take this is W, okay. W is a function of several variables actually. Some X, Y, Z, and some other functions are also there. This is a rough idea that how these functions are interconnected to each other. So if you try to calculate the variables, you will see. Now if you change the values, you will see the total taxable amount, the tax liability, the down, that is the bottom column is actually tax liability, how much one person has to pay actually the tax. If somebody's income is below 5,000 uh, per month, or if it is, then there is no tax. But if it is more than 50,000, then what will be the income tax? So tableau is actually the total, the original dependent function, and it is depending on x and y. That x and y are dependent also some other variable also. This can happen. And in that case, the formula for working for that, we will see this. The theorem 5 will give us the working formula. This is one rough idea. This is not exactly, but I have taken some. For example, if you that's net uh, annual income, for example, if the annual income is 7,38,000, and if the person opts for tax deduction, this is uh, it is called taxation. It is called rebate, tax rebate. Okay, some schemes are there. For example, PPF, then LIC scheme or medical insurance. If you do such kind of, then the tax will be, if a person do not opt for these cases, then the tax liability is 62,000 total tax liability. But if the person is actually opting for this, yes, then the tax liability will be reduced. The person has to pay less tax. See, the total function is actually same. Total annual income same. So if you can call it W, okay, W is a function of X, Y, Z, and also some other variables are also there. Now, if you try to find out, in fact, this income tax, TTL, total tax liability, is a function of the annual income. It is a function of annual income. And this W is a function of this X, Y, Z functions. In fact, I will show you one more data. If a person's basic salary is 50,000, then there are some added value added. For example, this would be HRA, no, sorry, DA. This is DA, 17% of the basic salary. Then traveling allowance will be, this is 3,000 of 6% of this basic salary. Then this will go to your retirement after service. Some person has to go to. So this is NPS for example, this is called Provident Fund, PF. The person will not get this much during the service time. The person will get after the service over. And also there is some employer contribution. Whoever may be the controller, after BTech you will be joining some companies. So this data will be actually important. In fact, you can relate to this. And also, not only that, if you income, if you have a net salary income, then you have to pay some taxes. There is some professional tax, there are some other tax. So the total income you can see here, the gross salary may be 8,48,000 the person, but the person will get only this much, 7,38,000. And also, this is the basic salary. But after adding this DA, TA, and all other facts, so this will be 70. And if you differentiate these two, from the net pay and the gross salary, you will have this minus this, you will get this value. And this is what? This is the total tax plus your PF. That is, you are saving for your retirement. But this is, you are not going to get back, because the government is spending on us, those who are studying, those who are teaching. Government is spending on us. So we have to pay our liabilities. This is our tax liability. You cannot escape this one. Okay. So if you sum this, okay, if you take the summation of these two quantity, then you will get this value. So this will be actually matched. So what happens here? So if you call this as a function W, which is a function of this function net pay, NP, then this is a basic salary. Okay, this basic pay. You can say BP, basic pay. Then it is DA plus TA plus NPS plus you can say TDS. Here it is EC, employer's contribution, and then you have TDS, In fact, this easy NPS is you can see on your slip, pay slip, NPS. But this amount won't be shown in the pay slip because the government is not giving. It is directly transforming to your PF. So this much amount will be saved for monthly for your retirement plan. And this is TDS, and you can say this is PT, professional tax. So this many variables are there: one, two, three, four, five, six, seven. So this cross, and this is actually sometimes this is plus. In fact, if you can know the structure, so this would be plus. This is plus plus. This is also so after here. This will be negative minus minus, and this is minus. So total deduction and total income net pay together they will form one function of several variable. Okay, so this net pay is a function of, in fact, gross salary also is a function of several variables. Now there are functions. In fact, uh, these can also be functions of some other functions. For example, oh, official king pin. Who is that guy? Who is there? Can you tell your name, Mr. Official Kingpin? So anyway, so there can be function w of x, y, z, and this both f of x, y, and z, and these are also x of t, a function of t actually. Okay, there can be function z of t. So in that case, the function working formula for this, because you want to find the rate of change with respect to t. So you cannot directly calculate the function rate of change of w with respect to t because w is dependent on x, y, and z, and this t are actually this x, y, and z are dependent on t. So if you want to calculate this rate of change with respect to, so you have to go through this. So that is why the dependency diagram is very important. Whenever we have several variable function, we go for partial derivatives. Whenever we have single variable function, we go for ordinary derivative. And the total derivative will be this one, total derivative. So you can actually practice for this case. Now there is another, it can also be extended to further generalization can be done. For example, both this w is a function of x, y, and z, and also this x, y, and z. They are some functions of r and s. So there are two independent variable and three intermediate variable. So these are independent variable, intermediate variables, and one dependent variable. Okay. So in that case, what will be the working formula? In fact, these proofs are not part of our syllabus. That is why I am not showing these proofs. So you have to remember this formula for calculating the partial derivative. In fact, a rate of change of w with respect to r, rate of change of w with respect to s. So because these are functions of several variables, okay. So in that case, we have to calculate the partial derivatives. Here also x is a function of r and s. So that is why we need to calculate the partial derivatives now with respect to r and then with respect to s. So this dependency diagram, try to remember them. Whenever we have function of several variables, we go for partial derivatives. If we have on single variable case, we will go for ordinary differentiation. So that's the basic idea of here. Okay. So try to remember this formula. And in fact, the working formula will be actually similar. When we had a d here, we have replaced d here. Okay. So we have delta here now, del here. Now you will substitute del. Now this will be clear if we solve one example. And this could be easy for two variable case if we have a only two depend intermediate variable, and then we have one, in fact another r and s can be there actually. So okay, so for this we try to look at the solution, try to prove this relation whether it is true or not. So z is a function of f of x comma y, where x is a function of e to the power u cosine of v. So this can be written as phi of u comma v. Y is a function of e to the power u sine of v. So this can be written as psi of u comma v. Now what we have to find, we need to show this relation holds. So for that, what we have to calculate? So for this one, we need to calculate first. So partial derivative, partial differentiation with respect to x and y. It will give us del z del x equals to, from here, if you remember, what we have to do, it is not del x, we have to find out the u, because finally we have to find out this relation. In terms of u, so this is a function kind of, here it is, z is there, here you have x and y, and you have here u comma v. Okay, so there, so this is the dependency relation here. These are intermediate, this is dependent, and this is independent. These are independent. Intermediate IM, independent, and this is dependent. Okay, so for that we need to find out del z del u, and for this one we have the formula del z del u del u, sorry, del x, so del x del u. See the formula here, r and s. Okay, so try to apply this relation. In place of r we have u, and in place of s we have v. R equals to u, s equals to v. So here we have del z del y, then del y del v, del u. Because when we talk about u, we will always have u. And since u, this x is a function of u and v. See here, Ax is a function of u and v, so that is why we have this. Similarly, we will have del z del v equals to del z del x del x. You will have del v plus del z del y into del y del v. So we need to find these two values. That's all we have. If we can find these values, then we will be, so we are through then. So let us calculate del z here. From here we get del x del u. So e to the power u into cosine v. So del x, in fact, del y del u. So e to the power u sine v. Similarly, del x del v minus e to the power u cosine, it will be sine v. So for here it will be del y del v. So this would be e to the power u. In place of cosine, now we will have sine. In place of sine, we will have cosine. Cosine v. Okay. Now we substitute these values in these equations. So first we will try to substitute the value in the first equation. Del z del u. So this is del z del x. In place of del x del u, what we will substitute now? We will substitute e to the power u cosine v plus del z del y into e to the power u sine v. So here we get, okay. So in place of this, we can write here x times, because this is nothing but x, again this is nothing but y, so x times del z del x plus y times del z del y. And we have to find out, look at the term, we have y is multiplied, so we multiply by y. So y times del z del u, this is x times y del z del x plus this is y square times del z del y. So call this one as 1. Similarly, we have del z del v equals to del z del x into, that was minus e to the power u sine of v plus del z del y e to the power u cosine of v, because this is for del z del v, sorry, del x del v, and this is for del y del v. And in fact we can see that this is negative sine e to the power u into sine v, and this is e to the power u into cosine of v. So we'll substitute here, but from the given equation we can see that this is nothing but y. Here you can see x. So for this we have y times del z del x plus x times del z del y. And if you multiply again with x, because we have to subtract, tell me. Yes, minus y will be there. Yes. Minus y will be there. So x times del z del v equals to minus of xy del z del x plus this is x square del z del y. So here we get equation 2. Now if you add these two, then this one and this one will get cancelled. Okay. So adding 1 and 2. Equation 1 and 2 we get y times del z del x or y times so just a minute. Yeah, y times del z del u. Yeah, del z del u plus x times del z del v. So this is nothing but x square plus y square times del 2 del what is there? Not this is del z del y. So in place of this case, you can write e to the power u cosine of v whole square plus e to the power u sine v whole square del z del y. So e to the power 2u, take common cosine square v plus here you get sine square v. So del z del y. So you get here e to the power 2u times del z del y. Is that what we have to find out? Yeah, it is there. So you need to find out this relation. Okay. Hence, the result is proved now. Now you can solve the equation 2 as usual. Just try to find out. So go through it, verify these results, and this one. We are supposed to get this relation satisfied. Okay. Now, if you just see more examples, for example, we have R, S, and T. Some more complicated situation because here U is a function of R, S, and T. Okay. Then what will be the then prove that this relation satisfied. So again, I will leave it as an exercise to verify this relation. So there you will try to apply this formula when we have three variables. Okay, and both the variables are actually functions of x and y, x, y, z. Okay. So in that case, you try to verify these results. Similarly, there is another example for which you again try to verify. And there are some practice problems. So let's say this is verified. Now, if you try to look at the function, for example, GDP is a function W, which is a function of f of this is C, G, I, and net nx. So there are four variables. In fact, this here is again function some x, and this is also function of y. It can be. This can be also function of z, some p. Here it can be some function of l and m, and this nx can also be function of some, for example, r and s. It is actually a rough idea. I'm giving one rough idea, but it's much more complicated calculation, and we need some more higher mathematics to understand this completely. The purpose of this example is to give you the idea of this chain rules. Whenever you have chain of function, okay, then chain rule can be applied here. This function, these chain rules are actually uh, applicable in case of GDP of a country. Okay. So these chain rules are actually applicable in case of GDP of a country. So let me just show you bigger. So here the functions actually, this is every country there have a GDP formula, a different formula. For India it is different, but this is for USA. Okay, the data is taken from the federal sources from here. So we'll have this kind of functions, and then we'll try to find out. For example, if you try to change the GDP, is actually it implies the rate. Okay. Then there are independent variables. So several. So GDP, for example, W, dW, dx. If you try to calculate, then what will be the change? In fact, if you write it in as a four functions actually, then what will happen? The rate of change. So in that case, you need to try the partial derivatives. In fact, dw, dx, del x, del w, del x, all these things. Because this consumption includes how much we purchase for goods and services. For example, goods, groceries are goods, but if you go for a haircut, then this is a service. Okay. Now, as much as we actually consume, consumption actually includes most part of the GDP. So this is consumption. Okay, this C is a function of, for example, some x and y, where x denote the groceries, the goods, and this y denotes the services. Similarly, government spending, G, government spends lot of money on students and faculties, and also roads, transportation, railway, all other things. So G means the government spending, and I means government investment. Not only that, this G function is actually another. For example, it is another phi. G is a function. G is a function of G of some. This is equipment. For example, equipment, infrastructure I. Okay, and this payroll, that means salaries. Okay, PR. So this is another three main variables are there. You have this function. On the other hand, investment. So how much they are investing on the science, technology, and then other actually, for example, equity and bonds. Although this is not of our part of our syllabus, but in order to understand the chain rule where it can be applied, that is the main purpose of today's this example. That these chain rules are actually applicable here in this case. Not only this case, in fact, in your electronic science, electronic engineering also, if you try to uh, a device which includes, for example, semiconductor and other things, okay, there also the functions will be several variable type. Okay, so if you want to generate, if you develop a device, okay, develop a semiconductor device. Okay. Then the cost the cost function will be functions of some several variables x, y, z, some w, and other things. Okay, there you will find the application of these partial derivatives and the chain rules of these functions. So cost function, for example, see w, not w. This is for example some other function. Here it is. So this, if you call this w as a cost function of all other things, then you have some raw material, you have some processing charges, you have some production or for advertising charges. All these are actually comes under the cost charge. So you need to develop one device which will low cost semiconductor device. Okay, there you will see the application of these partial derivatives and the chain rules there. Now if you look at the polar coordinates, so this is also simple case. So for polar coordinate, what we'll write, r equals to x equals to r cos theta and y equals to r sin theta. Now w is a function of x comma y. Okay, so here you apply the chain rule and try to verify the result. So in that case, you will see that this result holds. So I would say again to verify. There is nothing much to explain. This is just for chain rules. Similarly, these are for your practice problems. Verify. Yes, practice problem. Try to verify these results. So yeah, that's all for today.